What is speed? Huh? Magnitude of moving. Okay, that's a good definition. Okay, but what is the usual definition? Rate at which? Cover a distance. Okay. So generally we say it is distance by time. Okay. Now this is okay to say speed doesn't have a good symbol. Why? Because S should have been speed, but S is now displacement, and V is for velocity. So speed just happens to be SP. Okay. So speed, we write distance by time. It is okay, but not good enough, because this assumes that equal intervals of time you are covering equal distances. If it were uniform, then this is okay. But you may not be uniform. Like if this ball goes up and comes down, its speed was continuously changing. Okay. So, but what is speed? Well, whatever the speedometer shows is speed. You have an instrument like speedometer. So if a car is traveling, you just sit and watch the speedometer. That tells you the speed. So that's good enough. If the speedometer says 60, that means 60 kilometers per hour. Now the only problem with speed is that it is not a very real quantity. We can find it, but it's not a very real quantity. For example, if I take this ball and I'm going to throw it to you, catch this. Now when I threw it, did I give it a speed? Well, but did it get a speed? Yes. And did it move in that direction or this direction? Okay. So this time when I gave it some speed, it also moved in that direction. Can you throw it? So that time he actually threw it with a speed, but also had a direction. Now if I throw it like that, now I gave it this direction. And if I throw it like this, then this direction. Now wait. I would like you to just hold this ball. And now I want you to throw this ball with a speed, let us say 4 meters per second. But it should not move in this direction. It should not move in that direction or that direction or that direction or any direction. You should have speed but no direction. Because that's what speed is, no? But that has a direction. So can you throw a ball with speed but no direction? Yes, possible? No. Every time there is speed, there is also direction. So the real quantity we are going to deal with is not really speed, but velocity, because velocity is something that is what real quantity objects behave, right? So whenever you have a real object, you give it velocity. You can't actually give an object speed, because if I throw it, I have to throw it this way or that way or that way or that way. So some way. So whenever it's moving, it has a direction, whenever it has speed, right? So speed is a theoretical idea, which is why we don't have a symbol for it. Speed is the magnitude of the velocity, which means velocity has a direction and a magnitude. You just take the magnitude, you call it speed. Now this is the reason we don't have a separate symbol. Usually we put an arrow for velocity and we just take that part and say that is speed. So we use V to talk about speed, but this all assumes that it was uniform. What is the velocity of 3 meters per second this way? What does it mean? But what does it mean? It means 1 second you moved 3 meters, second you moved another 3 meters, another 3 meters, and so on. What about 0.1 seconds? Well, if you moved for 0.1 seconds, hopefully you moved 0.3 meters. That's the meaning of 3 meters per second. Every second you are moving 3 meters in this direction. Okay. Now what if I was moving at 3 meters per second in this direction for a while, 3 meters per second in this direction for a while, and then I was moving 3 meters like that and so on. So effectively I did this. Now which direction was I moving in? Not clear. I was moving in different directions at different instants of time. But overall I moved like this. I had what we call a displacement, and overall I must have taken, let's say, some amount of time. So let us say t seconds. So if we had a displacement of s, then we say displacement by time gives us some sort of an overall velocity. So this guy is called average velocity. Okay, so average velocity is a nicely defined quantity. It is displacement by time. This thing is not a very nice quantity yet, because though we can understand what velocity means, we have not defined velocity yet. We are saying if the velocity is 3 meters per second like this, I know what it means. But what is the velocity? That I have not defined. We won't define it for a while. Because to really define velocity, we need to talk about calculus, we need to talk about instantaneous velocity, because velocity means at every instant. If it is uniform and it is constant, it is nice and simple. But in this case, what is the velocity? I won't talk about it. What is the average velocity? That we will talk about, because that's easy. So let us start by first defining overall or average velocity. The average velocity is displacement by time. But you also, when you travel all this while, you have a constant speed, because I said we are moving at a constant speed, may not be. Maybe you are moving at 3 meters, then 4 meters, 5 meters, 6 meters. That thing is the velocity. The magnitude was the speed. But overall you covered some distance. The total distance that you covered by the time that it took to cover this distance is an overall speed. So that we call average speed. So I am going to call it SP average. So what is average speed? Total distance by total time. What is average velocity? Displacement by time. Why don't we use total displacement? Because displacement is total. If I go from here to there, I have a displacement. If I go from here to there, then for the total time, what is my displacement? This is my displacement. I don't have to talk about total displacement, because this is the total displacement. Displacement already incorporates the word total in it. So displacement by time is average velocity. Distance by time, total distance by time is average speed. Now these are averages. Okay. Now let us try and first understand this a little bit more carefully. I told you that speed at any particular point of time, not this speed. This is not a good definition. What is this? What should I have called this? Average speed. That's what we have defined it there. Okay. So speed is not distance by time. Average speed is distance by time. But we said if you take the velocity, which is what is real, because at some point if I throw it, it has a velocity. Now if you take the velocity and its magnitude, what was it? Speed. What do you think will happen if you took the magnitude of average velocity? What will you get? Will you get speed or will you get average speed? So the question is this equal to speed? Is this equal to average speed? It is neither speed nor average speed. It is just magnitude of average velocity. So look at this. Magnitude of velocity is speed, but magnitude of average velocity is not equal to average speed. Not equal to. So keep this in mind. Average velocity is a very, very different quantity compared to average speed. If I started with 4 meters per second speed and I change my speed to 5, 6, 7, 8, 3, 2, etc., my average speed will be probably somewhere in the middle. I started with 4 and ended with 8. Let's say nowhere I went down. So my average speed was somewhere between 4 and 8. But my average velocity may be 0. Why? I got to come back to where I started. Okay. So usually average speed never becomes 0. If you start moving, it doesn't become 0, because you already had some speed in the beginning. But average velocity many times can become 0. Every time you start from your house, go to school and come back, what's your average velocity? 0. What's your average speed? Not 0. Can average speed decrease? Yes, it can. Because right now when you came to class, when you started from home and you came here, your speed was something, average speed was something. Then all the time you were sitting here, distance wasn't increasing but time was increasing, so your average speed has been decreasing. When you go back home, actually your average speed will start increasing again. But when you go back home, your average velocity magnitude will become 0. Okay, so average velocity magnitude is not average speed. So you have to keep that in mind. Now, we are going to focus on average velocity and average speed for now. Later we will come back and worry about instantaneous velocity and instantaneous speed. One important idea I just want to specify, and then we will look at applying this to various problems and solving them. Then we'll understand this better. If you are moving for some time at 3 meters per second, and then you are moving for some more time at 5 meters per second, what is your average speed? I don't know. 4 meters per second? May not be. Because I may have been going at 3 meters per second for 1 second and 5 meters per second for 20 seconds. What is the average of 3 and 5? 4. What is the average of 3, 3 and 5? So 3 plus 3, 6 plus 5, 11 by 3, which is not equal to 4. What is the average of 3, 3, 3, 3, 3, 3, 3, 99 threes and 1 5? Well, 99 threes plus 1 5 is 99 into 3 plus 5, which is 100 into 3 plus 2, 102 by 100. So how much is it? 302 by 100, which is 3.02. So if I have 99 threes and a 5, the total is 302 divided by 100. So it is 3.02. It is almost 3. Does it make sense? It's almost 3. Yeah, you had so many 3s, you had only 1 5. The same way, this 3 could have existed for a long time and the 5 could have come for 1 second. Or that 3 could have been for 1 second and 5 could have been for a long time. So we don't know how many 3s we have, 3 meters per second. We don't say how many 3 meters per second do you have is not a good way in which we represent this in English. We say for how much time do you have 3 meters per second. How much time do you have 5 meters per second. Suppose I told you that I had 3 meters per second for 2 seconds. We will count it like it is 2 3s. Or we will count this as 6 meters. And then if this was for 3 seconds, we will count this for 3 rounds of 5, 5, 5, 5, which means 15 meters. So that's why the total distance will be 21 meters by total time, which is 5 seconds. And so that would be the average speed. So do you understand why we need the total distance? Because the total distance tells you how long you had this speed. Okay, how many of these 3s should you count? Now that is not coming out of the 3, that is coming out of the 6. Just like you did 3 plus 3 like that 99 times, you have to do 3 plus 3 2 times. And you have to do 5 plus 5 plus 5 3 times. But you don't know how many times. So usually what we do is, we do this speed into this time, which gives you the distance. So total distance by total time is the average speed. In fact, that's a good definition for average speed. Initial speed plus final speed by 2 is not average speed. Many problems it won't work. Okay, initial velocity plus final velocity by 2 is not average velocity. Mostly. Some rare cases it may turn out, like in case of uniform accelerated motion. When we study that, we will see that this works very well. In fact, it's a very good formula for uniform accelerated motion, but only for uniform accelerated motion. In general, not true. Okay, so in general what is true? Average velocity is displacement by time, average speed is total distance by time.